This is a video about the facade types that are often used in Dutch housing nowadays, although other facades are used too, and the types as discussed can also be used for other building types. The basis is a load-bearing structure like this in mostly concrete. These facade types show a build-up in layer groups. On the most inward layer group, the other layers are fixed, so the main function is a load-bearing function, but it is not necessarily the layer that carries the floor. Moreover, very often this layer has a subordinate role in the structure of the building and is only complementary. The second group has a thermal insulating function and regulates moisture transport within the construction. In many cases there is a gap between the thermal insulating layer and the outer layer, a cavity which has a function in the regulation of moisture. The outer layer group has the function of rain screen, a static layer, UV protection and impact protection. The inner layer can consist of blocks in brick, sand limestone or concrete in a wide range of sizes. The blocks sit on the edge of the floor. As these materials are not suited for bending moments, wind loads are transferred to the floor by the weight of the wall. If the wall isn't carrying the floor, there should be a flexible joint between the wall and the floor above, so the floor can bend freely without having a structural impact on the wall. There is a relation between the width of the opening and the height of the lintel above it, and the supporting brickwork on both sides of the opening. The inner layer can also be a plate made from concrete and nowadays also from cross-laminated timber. These elements are fixed on the four corners, bringing their weight via hinge connections to the support at the bottom, while rolling, flexible connections at the top prevent the wall from tumbling over and allowing the floor above to bend freely. The plate can transfer the wind load as a vertical beam to the main construction. Just as in a block wall, there should be material left around the openings, but in this respect cross-laminated timber is more flexible because timber can take more tension than concrete. The third type of inner layer consists of vertical posts or studs of wood or steel, covered on the inside or outside with a thin plate like plywood or chipboard. On the inward side, gypsum board is applied as fire protection and finish. At the bottom and top, the studs are connected with a horizontal beam. Studs, beams and plates form one structural element, made in a factory and transported as a whole. The center-to-center distance between the studs is determined by the dimensions of the plates, which are typically 600 or 1200 mm wide, so mostly 300, 400 or 600 mm. The studs are doubled or even tripled on both sides of openings for windows or doors, and on the top there might be a wooden lintel. Also here the opening is always inside the frame. The framework always continues around the opening. Between the studs, thermal insulation material is positioned. On the inward side of the insulation, a vapor barrier is needed, and on the outside, a bladder membrane protects the timber and insulation against the damp and moist in the cavity. The element is connected with a series of anchors at the bottom and the top. At the bottom, structural hinges, at the top, rollers. As in this wall, thermal insulation is incorporated in the wall itself, it doesn't need an extra insulation layer, but when the wall has to meet stringent insulating demands, a second layer of insulating material can be applied, which in that case covers the studs. Especially in the case steel studs are applied, this is necessary. The thermal insulating layer consists mostly of plastic foam or mineral wool. In some cases, a vapor barrier and bladder membrane are needed. The outer layer has the function of rain screen, a static layer, UV protection and impact protection. It can be grouped in four categories. The first type is a layer of glass fiber reinforced stucco in several thin layers with a typical overall thickness of 10 to 12 mm, directly applied onto the thermal insulation. The second consists of blocks such as fired brick, stone or concrete, laid in a pattern, a bond, and with lintels over an opening and window sills at the bottom. Openings are related to the dimensions of the blocks, in width as well as in height. The vertical load is transferred to a supporting element at the bottom, which itself is fixed to, by preference, the main load-bearing structure of the building. Horizontal forces are transferred by anchors through the thermal insulating layer, thus inevitably forming small cold bridges. The third type consists of a plate mostly in concrete, although also glass fiber reinforced concrete or polyester might be used. The element contains the openings for window frames. The plate is anchored on 4 points, by preference to the main load-bearing structure, not to the inner leaf. But in case the inner leaf is a concrete slab too, the outer slab can be connected to the inner slab. The last type of range screen shows by all means the widest range of variations. Here, thin plates, planks, boards, shingles of wood, metal, stone, glass or plastic in a wide range of dimensions are fixed on a system of rails or laths, which on its turn is connected through the thermal insulation with the inner leaf. In the case the inner leaf is a system of vertical studs, the anchors between the inner and outer leaves should coincide with the posts in the element. To conclude, we discern 3 types of structural layer: blocks, plates and a system of studs and infill. Thermal insulation has to be applied onto the block wall and the plate wall and into the stud wall. Extra thermal insulation can be applied on the stud wall. As outer layer we discern 4 types. The first is a layer of glass fiber reinforced stucco directly applied on a smooth thermal insulation. In the other 3, a cavity separates the outer layer from the thermal insulator. The outer layer itself can consist of blocks, large plates or a system of boards, planks, small plates or shingles fixed on a system of rails. All combinations of inner and outer layer are possible, but in case a heavy concrete outer layer is used, it can't be anchored to a block wall or stud wall and must be anchored to the main load-bearing structure.